For my final project in musical theory and education applications, I decided to work with my 8th grade students using project-based learning in mathematics. We are currently working with scale factor and ratios, so I had my class work on a project involving cartoon characters, music, and movement. A PowerPoint showed students the task at hand during each step of the project. Before students began working on the activity, we set some expectations for how to work with a partner. Students then chose a character they would like to work with from SpongeBob SquarePants. Each character had a different ratio of similitude. Once students had their character, they then drew a grid of squares on top of the character, according to their ratio of similitude. Students had to use measurement strategies and soon discovered that each character has different grid dimensions. Then came the part that most students really enjoyed, the large grid. Students were given butcher paper and chose to work on either the floor, desks, or even the walls. The enlarged grids posed a challenge to many students. Determining how to make the lines straight and mathematically accurate took some time, as well as much trial and error. Students were amazed to see that some characters, like Mrs. Puff, only took a small piece of butcher paper, while others, like Plankton, required several sheets taped together. The mathematical discussion was already taking place throughout the classroom. The next step in the project was for students to label both rows and columns on the small paper that had their character, as well as the large grid that they created. After labeling both the small and large grids, students then began working on their cell drawings. Some students' artistic abilities really came into play here. Yet even students who claimed to not enjoy art were able to make a very accurate enlarged drawing by looking at one cell at a time rather than an entire picture. The pictures were drawn and colored in. We were able to post drawings throughout the classroom as partners were finishing up. Then came the discussion. Students discovered that the length and width would get bigger by the scale factor. The area of the character is changed by the scale factor squared, and the volume was increased by the scale factor cubed. When the finished pictures were hung in the hallway, it was very impressive to see them all at once and compare how the different scale factors affected each character. Students used their knowledge and the pictures hanging in the hallway to respond to questions. To summarize all that was learned, 2 students performed a rap and the class listened to the lyrics. Please enjoy the very first production of Robinson Rhymes titled Similar Figures.
Take a polygon, and what did you say? It's a straight made of straight lines coming your way. A square, a triangle, a quadrilateral. There's a lot more. These are just the simple. Now take a polygon, it's your figure, and then create that image. It is similar. In math, a word similar, easy to learn. Just sit back and listen, cause soon it's your turn.
Similar figure, same shape, different size. Similar figure, same shape, different size.
The image can be bigger, that's a dilation. It can be smaller too, it's your creation. The most important thing when you're stretching and shrinking is the scale factor used. Now you're thinking. When two figures are similar, just compare the size. The scale factor tell you what was multiplied. Corresponding size on the figure in the image, ratios are the same. That's scale factor knowledge.
Similar figure, same shape, different size. Similar figure, same shape, different size.
When you're stretching and shrinking, the angles stay the same. A square is still a square, right angles is their name. The side lengths change by the scale factor is true. It don't double the length, you double the width too. The perimeter will change like the side lengths compare, but the area is affected by the scale factor squared. Two dimensions to apply scale factor to scale factor times the scale factor, what you need to do.
Similar figure, same shape, different size. Similar figure, same shape, different size.
Finally, the volume, let's take a look at that. A cube has three dimensions, length, width, and height. Multiply once, twice, multiply again. For a volume scale factor, cube is your friend. Now that's what happens when scale factor is used. Make an image a figure, it's real easy too. If you ever confused, sing along to these words. Same shape, different size, now you've heard.
Similar figure, same shape, different size. Similar figure, same shape, different size.